In Chapter 2, Part 1, we are going to start by looking at tile pattern investigation. So we are going to look at these tiles here, and we want to figure out by how much is this tile pattern A growing. So where are the tiles being added with each new figure, and we want to make the new tiles in each figure a different color. So if we take a look at Figure 1 to Figure 2, we can see that Figure 2 is adding a block in the first column and is adding 2 blocks in that last column. Going from Figure 2 to Figure 3, we are adding a block in the first column and adding 2 blocks in the last column. So when I look at Part A, by how much is tile pattern A growing? Well, we can see that it is growing by 3 blocks. So 1 in the first column and 2 in the last column. That is happening for Figure 2, and then from Figure 2 to Figure 3. So 1 tile is being added to the first column and 2 in the last column. Part B, what would Figure 100 look like for pattern A, and describe it in words? If we go back to Figure 1, Figure 2, and Figure 3 and count the tiles, Figure 1 has 7 tiles, Figure 2 has 10, and Figure 3 has 13. So each figure, if you look at the very bottom, that bottom row has 6 tiles in Figure 1, Figure 2, and Figure 3. You will notice the tiles are going up. It's not getting wider. So Figure 100 is going to be, it's going to have 6 tiles on the bottom. So then what we can do is go back to Figure 1, Figure 2, and Figure 3 and kind of see, is there some kind of connection. So Figure 1 has 7 tiles, Figure 2 has 10, Figure 3 has 13. After examining this, I've noticed that my figure number is the same number of tiles in that first column. So Figure 1 has 1 tile, Figure 2 has 2 tiles, and Figure 3 has 3 tiles in that very first column. So if I'm looking at Figure 100, there's going to be 100 tiles in that first column. The last column, I see a connection that we're going to take the figure number and we're going to multiply it by 2. So if I go back to Figure 1, 1 times 2 is 2, which is how many tiles are in that 6th column. For Figure 2, 2 times 2 is 4, and that's how many tiles are in that 6th column. And for Figure 3, 3 times 2 is 6, and there are 6 columns in that, or 6 tiles in that last column. So there's going to be, if I have 100, Figure 100, I'm going to take 100 times 2, so there's going to be 200 tiles in the last column. So that is what Figure 100 would look like. Part C, how many tiles would be in the 100th figure? So if we go back to Part B here, and we take a look at what we wrote, that we're going to have 6 tiles on the bottom. So that's going to be there regardless of what's going on. There's going to be 100 tiles in the first column and 200 in the last column. So we're going to take, so I'm just going to break this down and say that the first column is going to be 100 tiles. Then we have the last column, which we know is going to be 200 tiles. And then in between the first and the last column is 4 tiles. So I'm going to say tiles in between So if we add all of that up, there should be 304 tiles in the 100th figure. For part D, we are going to write an equation that relates the figure number x, the number of tiles y. So what I did is I made a xy table with x being 0, 1, 2, and 3, and my number of tiles, we know that for figure number 1, it's going to have 7 tiles, and we just got that from the picture. Figure 2 has 10, and figure 3 has 13. So we saw in the figure that we're going to add 3 each time. So if I want to find out figure 0, I'm going to work backwards. So 7 minus 3 is going to give us 4. So we are going to take this and create an equation. So we are adding 3 each time, and we're starting with the starting value of 4. So we are going to say that y is equal to 3x plus 4. And what you can do is you can go back and you can plug in 3 for x to make sure that it equals 13. Plug in 2, plug in 1, plug in 0. Alright, number 2, we're going to take a look at another tile pattern, and we want to start by looking to see how it is growing. So I'm going to kind of mark up my picture here. So from figure 1 to figure 2, they are adding 2 tiles. One in the far right column, and then they're adding another column. So from figure 2 to figure 3, same thing's happening. They're adding a tile to the far right column, and then they're adding a new column with a new tile. So they're adding 2 each time. So this is growing by 2, and 1 tile is added to the bottom of the far right column of the previous figure. So if I look at figure 2, you will see that this tile here is added on to the far right column of the previous figure, and then they add a new column where they put the other tile diagonal from the other new tile. In part B, we want to figure out what figure 100 would look like, and we want to describe it in words. So before we do that, let's take a look at figure 1, 2, and 3 and see if we can find some kind of connection between the number of tiles and our figure number. So figure 1, this has 5 tiles. Figure 2, if we add them up, has 7, and figure 3 has 9. I've noticed that the figure number, no matter which one we have, we are going to start with 2 tiles in this column. So no matter how many the figure number it is, we always start with the 2 tiles in that first column. Then it looks like the figure number is related to how many other 2 tile columns we have. So in figure 1, I have one other 2 tile column, and then I got that extra tile left over. In figure 2, I have 2 tile in 2 columns with that single tile left over, and in figure 3, I have 1, 2, 3 of the 2 tile columns with 1 left over. So there's a relationship between the figure number and these number of 2 tile columns. So figure 100 is going to start with 2 tile column, and then we will have 100 2 tile columns with the tile left over. So figure 100 would start with a 2 tile column, and then 100 2 tile columns with the column of 1 tile at the bottom right. So if we want to figure out how many tiles this would be, so if you think about that first column is going to have 2 tiles. So we're going to have 2 tiles, and then we will have 100 2 tile columns. So that equals out to 200 tiles. So we have 2 plus 200. 2 plus 200. And then we'll have that tile that is going to be added at the bottom. So this should give us a total of 203 tiles in the 100th figure. So if we go to write an equation, I'm going to set it up the same way by making a table. So my x is my figure number, my y is my tiles. We know that figure 1 has 5, figure 2 has 7, and figure 3 has 9. So we've already discussed that the growth factor, how much we're growing, is by 2. So if we work backwards, figure 0 would have 3 tiles. So we are growing by 2, so we're going to say 2x plus 3 is going to be our equation. And we can check it by plugging in any of the x values and solving for y. Number 3, we have pattern C, and it's represented by the equation y equals 3x plus 1. And we want to fill in the table for pattern C. So we are going to take each x value and we're going to plug it in for x. So if we start with 0, so we're going to say y is equal to 3 times 0 plus 1, which will give us 1. Then we'll plug in 1 for x, so y equals 3 times 1 plus 1, which will give us 4. And we can continue to do that with the 2, the 3, and the 4. So by how many tiles is pattern C growing? So if we look at 1 to 4, 4 to 7, 7 to 10, 10 to 13, you will notice that it's growing by 3. So each time it's being added by 3. So growing by 3 tiles. So what is the starting value? Well, that's going to be when x is 0, so it's going to be 1 tile. Where do you look in the table to see the growth value? So what we did, as you can see here, is we looked at the number of tiles, which is the y value, to see how it's growing. Now this is kind of a basic example. When we get into some more complicated ones, we will be also looking at our x value. But this is counting by ones each time, so it's kind of keeps it simple. So we are looking at the number of tiles for each figure. So where do you look in the table to see the starting value? Well, that is when our x is 0. So we're looking at the y value when x is 0. So we'll say y value when x equals 0. So where in the equation do we look to see the growth value? So if I go back to my equation, we have y equals 3x plus 1. So our growth value was by 3. So that's going to be the number right next to the x. Where do you look to see the starting value? That is going to be the number that's added or subtracted to the x. So number added or subtracted to the x value. Number 4, if we look back at the growth of patterns A, B, and C, imagine that the team next to you created a brand new tile pattern, but they refused to show the pattern to you. What other information would you need in order to predict the number of tiles in figure 100? Well, you're definitely going to need to know the number of tiles in figure 0, or actually any figure number, and the number of tiles added to each figure to help you find either the rule or to give you some kind of idea of what figure 100 would look like. Number 5, we are going to look at tile pattern D, And in part A, we're going to write an equation for the number of tiles in this pattern. We're going to use the color to show where the numbers in the equation appear in the tile pattern. And we're going to use X for the figure number and Y for the number of tiles in the figure. So before I do anything, I'm going to just kind of highlight the tiles that are being added each time. So from figure 1 to figure 2, we're adding 4 tiles. From figure 2 to figure 3, we are adding 4 more tiles. So I'm going to actually skip down to the table here and fill some of this out. So we know that figure 1 has 5 tiles, figure 2 has 9, and figure 3 has 13. So as we are going from figure 1 to figure 2 to figure 3, we can see that we are adding 4 each time. So figure 4 is going to have 17 tiles. And then we can work backwards to find figure 0, which we'll do 5 minus 4 to get 1. So we are adding 4 each time and starting with the number 1. So y is equal to 4x, because that's our growth factor, plus 1, which is our starting value. Part C, what is the same about this pattern and pattern C? What is different? Well, both patterns have the same starting value at 1. Pattern C is going to grow by 3, or pattern D is going to grow by 4. Part D, what would those similarities and differences between pattern C and D look like in a tile pattern? Well, both would have 1 tile for figure 0. That would be a similarity. The difference would be in pattern C, the tile pattern is going to grow by 3 tiles, and pattern D is going to grow by 4. So letter E, what do the similarities and differences in part D look like in the equations? Well, they're going to have the same starting value, which is the y-intercept, but they're going to have different growth factors. So for example, we'll have y is equal to 3x plus 1, and y is equal to 4x plus 1. So the plus 1s are the same, but these slopes, these growth factors are going to be different. And then part F, what do the similarities and differences look like in the table? Well, the starting value is going to be the same. It's going to be that 1, but every other number is going to be different. In example 6, we are going to write an equation that represents the tile pattern in the table below. So we are given figure 0, 1, 2, 3, and 4, and we are given the number of tiles. So we're first going to identify what is our growth factor. So how are we going from 2 to 7, 7 to 12, 12 to 17, and 17 to 22? And it turns out that all of them are going to be added by 5. So we know that the growth factor is 5, so we're going to have 5x, and we can identify the starting value because that's when x is 0, so that's going to be plus 2. So our equation is y equals 5x plus 2. Number 7, does the relation in the table above appear to be a function? If so, write the equation in function notation. If not, explain why it's not a function. Well, this is going to be a function because for every input there's one output. None of the x values are repeated. So we're going to say yes, and the function would be f of x equals 5x plus 2. In number 8, we are given a couple of pictures, and we want to describe how the pattern grows, number of tiles in figure 0, the equation, and if it's a function, we're going to write in function notation. So taking a look at our picture, the first thing I'm looking at is the number of tiles in figure 0. So here I am at figure 0, and we have 3 tiles. So we know that is the starting value. So we want to figure out how is the pattern growing. So at figure 0 we have 3 tiles. Figure 1 we have 7 tiles. So we're going from 3 to 7. So we're going to be increasing by 4. So we're going to say add 4. So our equation is going to be 4x plus 3. This is a function. It passes that vertical line test. So we're going to say yes, and the function is going to be f of x equals 4x plus 3. In part B, Again, I'm going to start with the number of tiles in figure 0, which they show us as 9. We want to see how the pattern's growing, and they give us this like a sloped triangle that shows us when we go over 1, we're going to go up 12. So every time we're going to be increasing by 12. So we're going to add 12. So our equation is going to be 12x plus 9. If we do the vertical line test, it passes through one time, so yes, this is a function, and f of x is going to be equal to 12x plus 9. Part C, again, we're going to start with the number of tiles in figure 0, which is going to be 3. We want to see how the pattern's growing, so if I see the couple points ahead, for every 1 unit, for 1 x value, we're increasing by 1 y value, so we're going to add 1. So our equation is going to be 1x plus 3. If we draw a vertical line, it passes the vertical line test, so yes, it's a function. So f of x is equal to 1x plus 3.